Okay, now that you understand your area model, let's use our area model to convert. Now let's look at this first example. Let me number it. It's example number 1. This equation is given to me in standard form, or expression is given to me in standard form. Remember, standard form looks like ax squared plus bx plus c. And I can tell that this expression does look like ax squared. A is 1. That would be my coefficient of my quadratic term. B is 11. That's the coefficient of my linear term. And C is 18. That's the constant that's at the end of my expression. And for us to be able to graph that quadratic function, we would have to convert it to either factored form or vertex form. We're going to start with factored form. I do want you to keep in mind that every quadratic equation or every quadratic function and every quadratic expression is not able to be factored using the area model, but most of them can be. So that's how, and I want to ask you to convert any to factored form that aren't able to be converted with my area model. So here goes. I've got a quadratic term of x squared. So I know I'm going to need one of these squares. Remember that this square is an x by x square. So it has an area of x squared. So by me bringing this portion into my area model, I'm taking care of that quadratic term. Okay, that's the easiest term to take care of. Now I need to have 11 x's. So I'm going to use 11 of these rectangles, but I want to do it in such a way that I will have 18 units. Now there's a lot of ways that 18 units, 1 by 1 squares. There's a lot of ways that I can arrange 11 just off the bat. Let's just play around here. I can extend a side by, let's say, 5. There, I've extended my side by 5, and I can extend this side by 6. And if I extend by 5 and extend by 6, then I've got 11x rectangles. I've got 11x rectangles. I could count them. 1, 2, 3. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Will I have 18 ones is the question. Now you can kind of think about this right here. If it's a 5 by 6, that's going to result in 31. So that's not the right arrangement. I could arrange 11 ones by having, let's say I extended this one a little bit more than 6. Maybe I extended by 10. Which means these guys, I'd only need to extend that side by 1, and then I've got 11x rectangles. Is that going to result in 18 ones? No, that would result in 10 ones. So what's the right arrangement? You've got to figure out the right arrangement that would add to give me 11, but that would multiply to give me that 18, as we can see that we've been doing here. So I start to begin thinking of factors of 18 that would multiply to give me that value that I need, the x's that I need. I want to multiply and get 18, and I want to add and get 11. So I can kind of use this little graphic organizer down here just to help me organize my thinking here. I want to multiply and get 18. I want to add and get 11. So let's start thinking about the factors of 18. 1 and 18. If I multiply, I get 18. If I add, I get 19, not 11. So that doesn't work. 2 and 9. If I multiply, do I get 18? Yes. If I add, do I get 11? Ding, 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 that's it. So I need to extend one side by 9, and I need to extend one side by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to delete this guy. extended that side by 9, and I've extended this side by 2. And then when I fill in my 1s, I'll have 18. Because that'll be a 9 by 2 portion of my rectangle. So I've extended my fill in correctly. The more you use the area model, the more familiar you'll become with it. And it's a very, once you understand it, it's a very simple way of thinking. You get to be very quick in coming up with your factors and how to arrange your area model. But it does require practice and perseverance. Stick with it and insist that you learn it. Converting becomes a very simple task once you understand your area model. Okay, so I've built it correctly. So now you are able to express the factored form of that. Remember, I've already been given my standard form, so there's no sense in writing that. The standard form represents the area on the inside of my model, so you need to give me the other representation for that area, which would be the length times the width. My length, remember, is my longer side, so in that case, it would be this portion of my rectangle, which was x plus 9. And this portion, which would be x plus 2, times x plus 2, which represents the width of my rectangle. So I know that in standard form, the quadratic expression x squared plus 11x plus 18 is the same as x plus 9 times x plus 2 in factored form. Those expressions are completely equal. We built it using our area model. All right, I'm going to jump ahead here. And let's jump to number 3. I want you to do another one that has all plus signs while we're getting the hang of it. Okay? So I want to build x squared plus 13x plus 12. Now for the x squared term, we all know it's my x by x. So this guy represents my x squared. I want to arrange 13 linear terms so that I will have 12 constant terms. So I need to think of it as my factors of 12 that will add to give me 13. So I start going through my factors of 12. 1 times 12. And when I'm going over factors in my head, I always start with 1 times whatever the number is. And I work my way up. I'll do 1 times that number, 2 times whatever factor, 3 times whatever factor, 4 times whatever factor. I usually don't have to go very far up before I get to my magic pair of numbers that will multiply to give me the amount of ones that I want and add to give me the amount of linear terms that I want. But do it in a systematic way. Don't just look at the problem and say, I don't know the factors. Actually start going in a systematic way. Get you a system that works every time. And I go in numerical order. That's a great tactic for you to use too. So once I find that my arrangement needs to be an extension of 1 and an extension of 12, I can build my model. And I really should build this with no gaps. That last one wasn't a very good build because I'm extending by units. There wouldn't be spaces in between. I want my model to look like one smooth rectangle when I'm done. So we're starting with a square. We're transforming it to a rectangle to build this quadratic function. All right, I'm going to do a cheat method here. And let's just copy those to make me 6 more. And then I extend the other side by 1. Get it a little bit closer. And when I fill in my 1s, I've got 12 of them. So I know I did it correctly. and it fits. It makes me a rectangle. It's exactly what I want. If I look at my linear terms, I've got 13x of them, and I count my constant terms, I've got 12 of them. So I know that I can think of this side as my length, which would be x plus 12. This side is my width, which is x plus 1. So x plus 13x plus 12 in standard form is the same thing as x plus 12 as my length times x plus 1 as my width. Okay, very nice. All right, let's stop it there, and we'll look at the negatives on the next video.